Hello, my mathematicians. Today we are looking at lesson 4 of module 7, which is all about renaming mixed numbers to subtract. So I can subtract mixed numbers by remaining. Hopefully this is what you can do by the end of the lesson. Step it out. Number 1, Larry rides his bike to the park. On his way home, he gets a flat tire. How far does Larry have to walk his bike to get home? Write an expression for the problem. Well, as you can see from the map, we are going a total of 3 1/4 miles to get from home to park. So that's what we're going to start with. We're going to start with 3 1/4. And then he has gone 2 3/8 of the mile. So 2 3/8. So that would be our problem. So it says use fraction strips to represent the distance Larry rode to the park as equivalent fractions with the denominator of 8, and then write a new subtraction expression. Well, we're just going to write our equivalent fractions. So if we have an 8, we have 3 1/4. It's going to equal 3 and something over 8. Well, we multiply the 4 by 2. 1 times 2 is 2. So we're going to have 3 2/8 minus 2 3/8. So if we think about this, it says, do we have enough fraction strips to subtract the fractional part of the distance Larry rode? So if I have 2/8, can I take away 3/8? And the answer would be no. The fractional part of the first number is less than the fractional part of the second number. So how can you represent the distance Larry rode to the park using fraction strips so that you are able to subtract the distance Larry rode home before he got a flat tire? Well, you could exchange a whole for 8 fraction strips because 1 whole 8 eighths equals 1 whole. So we could exchange 1 whole for 8 1/8 fraction strips. So it says represent the exchange you made with fraction strips using mixed numbers with an equation and subtract. Well, if I now have 8 1/8 fraction strips plus the original 2, so I would have 2 8/8 plus 2/8. That's going to equal 2 10/8. So we have 2 10/8 minus 2 3/8. So we get 2 minus 2 is 0, and 10/8 minus 3/8 is 7/8. So how far does Larry walk in his bike home? 7/8 of a mile. We're going to go to the next page. So the students in a 5th grade class and a 4th grade class ate some pizza. How many more pizzas did the 5th graders eat than the 4th graders? So write an expression to model the problem. So the 5th graders have 1, 2, 3, 4, 5 pizzas, 5 whole pizzas, and 1 out of 1, 2, 3, 4, 5, 6. So 1/6 minus the fourth graders have 2 whole pizzas and 2 out of 3. So to estimate this, 5 and 1/6, so basically 5. And 2 2/3 is close to almost 3. So it'd equal about 2. So since find a common denominator, use the common denominator to write mixed numbers with equivalent fractions. Well, we have 6 and we have 3. So we go 6, 12, 18, 15, 3, 6, 9, 12. So 6 is our least common denominator. So that means 5 and 1/6 is going to stay the same. And then we are going to do our 2 and 2/3. It's going to equal 2 and something over 3, or something over 6, excuse me. So we're going to times the 3 by 2, and we're going to do 2 times 2 is 4. 2 and 4/6. So it says you can subtract mixed numbers by renaming both numbers as fraction greater than 1. So what they're saying here is we can write 5 and 1/6 as an improper fraction, and we can write 2 and 4/6 as an improper fraction. And the way we do this is we take however many 6 are in a whole, so there's 6, and we multiply that by our whole number. So 6 times 5 is 30, and then we add our numerator, so we get 31/6. And we do the same thing. There's 6 in a whole, so 6 times 2 is 12, plus the 4 is 16/6. So we can write that. So 5 and 1/6 equals 31/6. 2 and 4/6 equals 16/6. And then we subtract. So we would do 31 minus 16 is going to be 15/6. And then we want to rewrite that as a mixed number. So 6 goes into 15 2 times with 3 left over. And you can see that by doing 15, 6, 2, 12, 3. So 2 and 3, 6. So how many more pizzas did the fifth graders eat than the fourth graders? And it'd be 2 and 3, 6 pizzas, which is also the same as 2.5. So is our answer reasonable? Yes. My answer is close to 2. We're going to look at the next page. So it says Sarah measures how much water her horse and donkey each drank. How much more water does the horse drink than the donkey? This is what expression can you write to model the problem? Well, each one of these is a liter, so 1, 2, 3, 4, 5, 6 minus 3 and 6/10. Now, can we subtract the fractional part from the whole number? So it'd be no. There is no fractional part for the whole number. So there are no tenths to subtract from. So it says rename the whole number to subtract and explain the process I use. Well, if I take away one whole, that would leave me 5. And then I would take that one whole and I would put it into tenths. Well, how many tenths are in a whole? There are 10. So I would get 5 and 10 tenths. So basically, I renamed 6 as 5 plus 10 tenths because the fractional part of the mixed number is 6 tenths. So to find the difference, we'd have 5 and 10 tenths minus 3 and 6 tenths. So 5 minus 3 is 2. 10 minus 6 is 4. So we'd have 2 and 4 tenths. So how much more water does the horse drink than the donkey? It'll be 2 and 4 tenths liters more. So that is all for today's lesson. Hopefully you are now able to subtract mixed numbers by renaming. Remember, in order to be a math person, all you have to do is be a person and do math.